Good day, folks. Good day, folks. Good day, folks. I hope you are all doing very well across different provinces. I greet you. I greet you today, and I'm excited to look at another question number 2 as far as the nature of roots is concerned. Then, as the part of the journey that we are going to embark upon, is whereby we are going to take, or I'm going to take learners that are doing technical mathematics through sections of previous question papers from different provinces. And I've started to treat questions from the year 2022. Now, as the purpose of today's lesson, we are going to indulge question number 2 from the Department of Basic Education, Eastern Cape, June 2022. That is question number 2 from Eastern Cape. Then, without wasting any of the time, let us indulge the questions that we have here. Question number 2, which is the nature of roots. Then 2.1, that is the question that we are going to look upon. Then 2.1, it reads as follows. It says, describe the nature of roots of 0 that is equal to 2x squared plus positive 5x plus positive 8. It says without solving the equation. Now let me explain the last part that says without solving the equation. Taking a note from my previous lesson as far as the question number 2 is concerned is that in question number 2, candidates, you are not supposed to solve for those distinctive solutions of x using the quadratic formula or using factorization. In question number 2 is whereby we are required to describe the kind of roots that we can expect from a given quadratic equation without solving the equation, meaning without applying the quadratic formula or without applying the factorization. Now, how do we describe the nature of roots? You can't describe the nature of roots without first determining the discriminant, the value of the discriminant. What is the discriminant? Discriminant is delta. Now the question is, how then do we get the value of delta? Let us first write the formula that defines the discriminant. The formula says delta, which is the discriminant. It says delta, which is the discriminant. This is delta, which is the discriminant. That is equal to b squared. B squared minus 4ac. This is the formula that we are going to use in question number 2 to find the value of the discriminant, to find the value of delta. Now, after you shall have written the formula from the formula sheet, if it is given, I don't think it is given, you must know the formula by heart. The formula says delta, which is the discriminant, that is said to be equal to b squared minus 4ac. Now, after you shall have written the formula, now you must go and substitute. Remember, the value of b, it is the coefficient of x and its respective sign. The value of a, it is the coefficient of x squared and its respective sign. And c, it is the constant, is the number without an x. Now, let us go and substitute using the quadratic equation that has been given to us. Equals to, now remember, if you have to substitute, please always have brackets. Remember, it says b squared. I start with the square. Now for substitution, I introduce bracket. From the given equation that we have here, remember, we must go and look for x. Here is an x. The number before an x, that is going to represent the b. In this case, the value of b that we have here is positive 5. Now we go further to substitute. Minus 4. We are going to substitute the value of a. Remember, a it is the number, is the coefficient of x squared term. Here is our x squared term. The number before the x squared, here it is positive 2. Positive 2 represent the value of A. And lastly, we are going to substitute the value of C. What is C? The constant, the number without an x. The only number without an x here is a positive 8. Now 8 represents the value of C. Now we have fully substituted, correctly substituted into the formula of this discriminant. Then how do we award the mark? 1 mark for correct substitution into the correct formula. Remember, in technical mathematics, wrong formula, 0 mark. What do I mean? If here you use the quadratic formula to find those distinctive solution of x, you get a 0 because you have used the wrong formula. Wrong formula, 0 mark. Now, after we shall have substituted into the correct formula, we are going to use our calculator to press everything that we see there so that we are able to get the value of the discriminant. Then we are going to say, therefore, because now we are going to get the value of the discriminant. Here it is, therefore, delta. Therefore, delta, it is equal to so. Now, let us go and substitute, let us go and punch that into our calculator. 5 squared minus 4, open bracket, 2, close bracket, open bracket, 8, close bracket, equal so. Now, the value of delta that we have here is negative 39. Then how do we mark also? We are going to mark here the value of what? Of delta, which is now 2 mark. Then lastly, how do we now describe the nature of roots? Now, for you to describe the nature of roots, you check the value of delta. Now you must recall all the prescript. You must recall all the conditions of the nature of roots. The first condition, it says, if delta it is greater than 0, meaning that if you get the value of delta here, if you get the value of delta here to be a positive number, and if that positive number it is a perfect square, then the prescript, the conditions are as follows. It says delta is going to be a real number. Oh, the roots are going to be real, the roots are going to be rational, and the roots are going to be unequal roots. If only delta here it is a positive number that is also a perfect square. Then condition number 2, it says, on the same breath, if delta it is a positive number, but if delta it is not a perfect square, which numbers are not classified to be perfect square? 2, it is not a perfect square. 3, it is not a perfect square. 5, it is not a perfect square. 7, not a perfect square. 8, not a perfect square. 10, not a perfect square, and other numbers that are not perfect squares. Then it means the prescript, the condition will be real roots, irrational roots, and lastly unequal roots. Now please go and revisit those prescripts, those conditions. Now the value of delta that we have here, it is a number that is what? Negative. Now, if delta it is a negative number, the roots are going to be non-real roots. Meaning that the roots of this quadratic equation, the solutions of x are going to be non-real roots. Meaning that the roots are not going to exist. We are not going to get the solutions of x. The other word that we can use is the word imaginary roots. Imaginary roots. 1 mark for correct substitution, 1 mark for the value of delta, and 1 mark for describing the type of roots that we are going to get. That is 2.1. Then 2.2. Mark allocation for 2.1, 3 marks there. Then 2.2, it says determine one value of the smallest positive integer. Remember, the word integer, it means positive and negative whole numbers. But in this case, it is clear. It says positive integer. Which numbers are positive integer? 1 is a positive integer, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Then the question says, determine one value of the smallest positive integer k, for which the equation 5x squared minus kx minus 2 equals to 0 will have rational roots. Now, here we are given a condition here to say rational roots. We are required to find the value of k, the positive integer k, for which this value of k, it is going to give us this condition, which is what? Rational roots. Now, since we have set 1, we go to condition number 1. For us to have rational roots, one rational roots, delta, it must be greater than 0. If delta is greater than 0, we are going to have rational roots, one rational roots. Now we go and write this condition in an equation form. To say, for us to have rational roots, let us write that. For us to have rational roots, delta, which is the discriminant, it must be greater than 0. It must be greater than 0. It must be greater than 0. Then we are going to have rational roots. We are going to have rational roots if delta it is greater than 0. Now, what is delta? Delta from its primary equation, delta is equal to b squared minus 4ac. Now, let us go and write what is equal to delta. In this case, delta is equal to b squared. Now, let us write that first. B squared minus 4ac. On the same breath, it must be greater than 0. Then writing the formula, no mark for writing the formula. Then from writing the formula, we must substitute. Then from this quadratic equation that has been given to us here, remember, b, it is the coefficient of x. Anything that comes before an x, it represents the b, and you write it with its respective sign. Then a is anything that comes before an x squared term, and c is any number without an x. Now let us substitute into that equation of delta. Then we start with the square. We substitute the value of b in brackets. Now we go to an x. Here it's an x. What number or what letter do we have before an x? Here it is. This negative k, it represents the b. Where we see b, we write negative k, which is negative k squared, minus 4, open bracket. The value of a, we go to x squared term. Then the value of a in this case will be positive 5. Write the 5 here. Then the value of c, it is the constant number without an x. In this case is negative 2. Same, it must be greater than 0. Now from here, 1 mark here for the correct substitution into the correct formula. 1 mark for delta, it must be greater than 0 using what? The word rational roots. Then you have 2 marks so far. We must then now simplify. We must now simplify. Then anything squared, regardless whether it's negative inside the bracket, because of the square outside, then it means the whole thing here, it will be a positive. Then let us go and simplify that. Then from open bracket, negative k squared, the answer will be positive k squared because of the square outside. Positive k squared Then we must punch everything that we see in here. We must punch everything that we see here on the calculator. Minus 4, open bracket 5, close bracket, negative 2, close bracket, equals to. Then we have minus 40, still greater than 0. Then from here, remember, we are looking for the value of k. It says one value of the smallest positive integer. That is going to give us what? Rational roots. Remember here, you can't solve for k here. Oh, because of this negative, because of this negative before the 4 here. Before the 4, if you punch the whole thing into the calculator, you get a positive 40. You get a positive 40 here. You get a positive 40. Now, if you can try to maneuver to find the k here, you are not going to find the k, because now, if you transpose the positive 40 to this side, and you introduce the square root here, you introduce the square root of negative 40, then you are going to get the k, which is what? An error. Now, we stop here. This is going to help us to find the value of k. Remember, we are looking for one smallest value of k. That is going to give us what? That is going to give us the rational roots. Remember, for us to have a rational roots, the whole thing here, which is the discriminant, it must be a perfect square. Then, we must find the value of k, such that when we plus it with the 40, we are going to get a value here, the whole value here, to be a perfect square. Because we understand that if this value here, if the discriminant is a perfect square, therefore the roots will be rational. Then we start from what? They've said to us smallest positive integer. We start from 1. Where we see k, we substitute 1 to see if we plus whatever that we get here on the k with the 40, are we going to get a perfect square. Then 1 squared, it's 1. Then 40 plus 1 is 41. 41 is not a perfect square. Therefore, k, it must never be equal to 1. Then we go to the second positive integer, which is 2. Where we see k here, substitute 2. 2 squared, it's a 4. Then 4 plus 40, it is 44. 44, it is not a perfect square. Therefore, k must never be equal to 2. We go to positive 3. 3 squared, because we are saying k is equal to 3. Then 3 squared, it is what? It is 9. Then 9 plus 40, it is 49. Therefore, then 49 now it becomes what? A perfect square. And if delta it is a perfect square, we are going to have what? Rational roots. Then which value of k is going to give us a perfect square? Then we draw a conclusion to say therefore, therefore k, it must be equal to positive 3. Why? Because if we take 3 and substitute to where we see k, we are going to have 3 squared, which is 9. 9 plus 40, it is what? It is 49. And if delta, it is 49. 49, it is greater than 0. And for it to give us the rational roots, it means delta, it must be a perfect square that is greater than 0. And now, if value of k is 3, we are having a perfect square here. A perfect square that is what? Greater than 0. That's why the value of k, it must be 3. That's why we're saying the smallest. Then 1 mark for writing delta must be greater than 0. 1 mark for correct substitution. 1 mark for simplification until here. And 1 mark for the value of what? Of k. Then mark allocation there, 4 marks. Total mark for this question, it is 7 marks. If you have any question, please do that via the comment section. Then I will address all relevant questions that you have. Thank you so much. I will see you in my next video, where I'm going to take you through question number 1 of the same question paper that we were doing today, which is the Department of Basic Education, Eastern Cape, June 2022.